In this video we're going to talk about just-in-time systems. Now you'll see from the slide it's part 1 of 4. There are 4 videos on this topic, and of course each of them should be viewed. It's an important topic within the business literature, and it's one that is often considered. So we often talk about JIT, or just-in-time ways of production. So let's look at what's meant by JIT. Well, it's sometimes referred to as lean production. So just-in-time, it's a repetitive production system in which processing and movement of materials and goods occur just as they are needed, and usually in small batches. So just-in-time is when production is synchronized. It's connected very efficiently so that the output from one process runs directly into the next process. There's no waiting. It's as if all of the different functions of the business operate as one function, so that raw materials, let's say, come from a supplier. The raw materials are synchronized. The amount of the raw material and the type of raw material is synchronized with the type of requirements for the first stage of the production process. So the items arrive, they go straight into production. They don't go into stores. That's a waste of effort. Putting them into the stores, leaving them to wait for some time, and then having to move them out of stores. That's wasteful. So instead, they arrive and they go straight into production. And the output from the first process is perfectly synchronized with the requirements of the second process. So they go through the first processing and they move smoothly into the second processing without waiting. So everything is connected. And that's what we mean by JIT. It's just in time. Everything happens just in time. No waiting. JIT is characteristic of lean production systems. So there's no wastage in the system. JIT operates with very little fat. In other words, there's very little wastage in this system. Everything runs efficiently. Everything runs smoothly. All the machines are connected up so that the output from one runs smoothly as an input into the next until the final product is reached. So there's no waiting around. There's no inefficiency. It's a very lean and efficient system. So the JIT goals are to eliminate disruptions. Clearly, if there's a breakdown anywhere in the system, it's going to cause the whole system to have problems. So it's important that the machinery runs smoothly, that it's well maintained, that the workforce are adequately trained and are skillful in their requirements. So there are no disruptions in the system. If there are disruptions, it can be a major problem, because if there's a disruption early in the system, early in the production system, then all of the subsequent processes will be delayed as well. So make the system flexible by reducing setup and lead times. So once the system is set up and running, then there's no more changing over the system. It is now configured towards the production of that item. And there's no waiting or lead times involved. The items run smoothly from one process to the next. It eliminates waste, especially excess inventory. In fact, in a JIT system, there will be no need for stores. There's no need to hold raw materials in stores. The raw materials go straight into production. It does not make excess components which have to be stored. It makes enough components to see out the current orders. And the items at the end of all of the production processes, they are delivered to the customer. So in a sense, it's the customer that's pulling the production through the system. The customer places an order and that pulls the production through. The order needs to be completed. The customer has placed an order and it needs to be completed. So the organization then sets up the raw materials and all of the various processes, and the orders, the customer orders, are pulling through the production, pulling it through the system. Now the sources of waste, well, overproduction, and that's typical in non-JIT systems, that sometimes companies may produce batch output. So some items will be overproduced and will go into stores, hoping that the customers will place subsequent orders and the subsequent orders can be met from store supplies. So sometimes companies overproduce. But of course overproduction is a waste. It's a waste of raw materials, it's a waste of effort. Those items, whilst they're in the stores, are standing idle. They're not producing any revenue for the organization. Waiting time is a waste. When machines have to wait for the next process to start, or when workers have to stand around waiting for something to happen, waiting for the next part to come through. So by synchronizing all of the various functions, there's no waiting time. There's no waste, in other words. Sometimes there's unnecessary transportation. Unnecessary transportation because, let's say, items have to move from one part of the organization to another because the machinery are not properly set up, so it has to go from one part of the organization into another to have a different process done. So for example, let's say a particular item needs to be produced by certain machines, and then it may have to go away and be painted in a different part of the organization in a paint shop, and then returned, put back on the production system, and the processing completed. There was unnecessary transportation in the system. Could the painting, or could that work not have been done in situ? So it's important to try and eliminate unnecessary movement. And looking at processing waste, looking at the optimum design of the item and buying in configurations that minimize waste. So if it's an item that's going to be cut from wood or cut from metal, buy an appropriate shape of metal so as to minimize the processing, minimize the work to be done. Also, inefficient work methods. Sometimes workers may have traditional methods of working that they were taught when they were apprentices or when they first joined the company. But these are now antiquated. These are out of date. There's new technology that could be used, new ways of working with machines and working with people. So inefficient work methods have to be reviewed. And of course, product defects are a serious issue because all the work that's been put into the product is wasted because of the defect. So for example, if the product does not meet the tolerances required by the customer, or the product is the wrong dimensions, or has some defect in its design or in its production, then the product is wasted, and all the effort that's gone into the product up to that point is also wasted. Now, big versus little JIT. For a start, big JIT, big just in time. This means a broad focus. A broad focus means looking at vendor relations, looking at seller relations, looking at looking at all parts of the outside relations in effect. It should look at customer relations and make sure the customers just get the amount that they want. Don't overproduce. But it could also look at the buyer relations under this heading if we wanted to, and ensure that the orders for raw materials and stock is just sufficient to meet the order books. But of course there has to be a good relationship with the buyers to make sure that the raw materials and the supplies coming in are good quality and there's no wastage or inspection costs, expensive inspection costs required. There should be good human relations. It's important that the personnel within the organisation understand the philosophy and understand the need to be efficient, and they subscribe to it, and that they themselves perform their tasks in a way that is compatible with the overall design of the organisation. And the technology should be adequately managed. In other words, it should be understood and it should be programmed and it should be set up and configured in an optimum fashion so that it runs smoothly within that integrated process. And there should be materials and inventory management. In a real JIT environment, there will not be inventory. But it may be felt by some organisations that some small amount of inventory may be required for special items that are required by customers, or perhaps fluctuations in demand at certain times of the year, and they wish to hold additional inventory just to meet those. Or it could be indeed the company wishes to hold materials in stock, some materials, because of the fear of an increase in price, for example, of raw materials coming into the organisation. So they want to buy at the current price to avoid future price increases. So it's important that they try to work out what is the optimum given the overall philosophy of JIT. Now little JIT is a narrow focus. So it's not covering the whole organisation in a sense. The broad focus is covering just about everything. The little focus just looks at scheduling materials, getting the materials to the right place at the right time, getting them there in sufficient numbers. But it's not concerning itself with much of the broader issues that we considered above. And also scheduling the services of production so that production capability is available when required, and it's linked or synchronized with other stages in the production process. Again, within this narrow focus, you can see there are only a couple of areas where JIT would be applied, and perhaps in the context of human relations or vendor relations or technology management, that's left to, in a sense, a non-JIT environment. So these are some of the issues that we need to consider when we're starting to look at just in time. This is the first video of 4, as I said before, and it's important to look at each of them and make good notes. This is an important topic, one that is often discussed in the context of business. But let's leave this first video now and leave it at that and say thank you for watching.